Hi everyone, and welcome to flm204 here at Effects PhD. I'm John Montgomery. My apologies for my voice this week. I'm not feeling very well, in fact feeling quite terrible, but in good spirits. And as they say, the show must go on, and I want to get this out before the end of week 5. So hope you can handle my little scratchy voice today. We're going to be looking at today is starting a look at the eval function, which allows you to manipulate expressions in time. And it's really one of the cooler things about expressions that you can do. And we'll also talk a little bit about just some theoretical stuff of how you set up expressions just to make things really flexible. So I think that's going to be a lot of fun in the second half. But the first half, what we're going to do is actually take a look at the extended bicubic resizer, which has always been a favorite. And what I want to do is actually show the process of how we did that and how it came up with that actual effect, because it was actually given to us by Evan Shoemaker at Charlex years ago at Effects Guide, as well as John Boudin at Rhino, as well as Greg Oyen at Charlex. All kind of helped us with their varieties of it, and even C.E. Ram, who I went on tour with, helped us. So thanks, guys, for that. But the idea behind it, and what I want to show, is just philosophically how to figure out how to do these things. The idea is, you know, if you wanted to focus on a certain part here of Angie, like her tattoo, and warp it, it's actually quite difficult to do because you just take the extended bicubic and you would subdivide it, and now I finally have that fine tuning. But what's cool about this is that we actually have an axis here that we can actually take and scale and then reposition here as well. Scale it down. And then have really fine control of this area. And what's happening, if I go ahead and I'm going to turn off the back, you can see that we have an extended bicubic which is retaining its full size, but then I have a source here. It's actually resizing the image quite big and then shrinking it down. So there's some interesting math going on, but how do we actually figure this out? And then how do we make this applicable to a scene like this where we have in animation, we want to track our bicubic and so forth. So let's go ahead and dive in and see how we created that. First off, I'll go ahead and add by extend bicubic, add that in, and like we always do, let's go ahead and put repo me, because I'm going to make this, again, one of those philosophical things about expressions. I want to make it as obvious as possible and as reusable as possible. So when I load up this setup again, or add nodes plus layers with this, I know exactly what I'm doing. So I want this to be clear, because I might touch this, might not touch this for a couple months. So you want it to be clear. Okay, so we'll have a repo me here. And then what we want to do is go ahead and add our front source node. And that's just going to be the same image. And let's just start out really easily with what we're doing here. Let's go ahead, I'm going to switch up to 2-up view. Let's go ahead and look at my source node over here, that's F6. And then we'll just toggle over here on this side to the repo. And what I want to do is, as I scale this down, I actually want this to actually scale back up here in my source. Now, I'm not going to move anything around at this point, right? I'm going to want to leave it here where we're at. So we scale it down. So basically, all I really did is start just really with expressions, trying to figure this out, and starting with kind of simple values. So if I take my repo me here, and I'll set this to 50. And take a look at it. And then I'll go over here to my source and just try and get this to kind of scale up to where I think it matches. If we take a look at this, you can see it's, you know, lo and behold, around 200. Probably no coincidence here at all. So what you do is you just kind of start going, okay, so what do we end up with to get 200 in this value here as a result? And basically that ends up being dividing 10,000. Let's go ahead and do this just to scaling. I believe, let's go ahead and reset this. I'm going to enter in an expression that would be repo underscore me dot scaling. And basically if we take this divided by 10,000. And let's see if that works. My math's right. So sure enough, that's the math that's working with that. And, you know, it's generally good to find those values like 50 or whatever, you know, easy values that help you calculate to figure out what's going on when you're starting to work with math. So we've got our scaling right, or I think we've got it pretty well nailed. Now let's worry about the position and see what we need to do in order to get that straight. Basically, when we move Let's come over here. When we move this position up, what do we need to have happen in the source node? Basically what needs to happen, and you can see this here, you can see that what I would need to do is actually shift this position down. In other words, counteracting the positioning that's going on before. So what's that? That's minus position, negative position. So let's go ahead here, and this is our axis 1. We'll enter in the expression here, minus repo underscore me dot position. Okay, when we look at it here, let's go ahead and take a look at it. It does not look correct at this point, okay? It seems to be kind of what we're doing, right? As I reposition this down, and so, oh, that's the wrong image. This is what I need to reposition. As we reposition this, it does seem to be reacting, but something's going on here. Well, don't jump to conclusion that the expression's actually broken at this point. What's happening here is our scale value is causing a problem. So what we'll do is let's go ahead and reset our scale value to 100. And now, if we go ahead and position this, you can actually see that the position functionality is actually working correctly. A really nice way to see that is we'll go in and we'll color correct our background and kind of bring the offset up. And you can see now that our background is the washed out flavor. And here's a repoed by Cubic. So actually, what's happening right now is the repositioning is actually working correctly for us. It's actually repositioning. What's happening, though, is when we start scaling it, that's when we have a problem, okay? That's the issue that we're running into when we're scaling. Okay, so why is this? What's going on, and what do we need to kind of counteract this issue that we're having with scaling? What needs to happen is, notice that if we take a look here of our background, you can see that our center point is actually over here on this corner. Okay, so the scaling should actually be occurring around the center point. But what's happening with us is you can see that the scaling is actually happening here on our cheek because this is that axis. Okay, so when I scale this, you can see the scaling is happening over here when in reality it should be happening here in the center of our image. All right, so what do we need to do? Well, we need to actually adjust the center here via an expression. So what we need to do, where is this center? Where is this? Well, all it is, it's just over here, position X, and 296, 296. So let's go ahead and enter our center here. And if we go ahead and say repo me dot position, and now let's see if that works. Go ahead and scale this down. Yeah, now that's working correctly. So we're getting our scaling correct and our positioning correct here. So it works out really well. So that's the basic setup, and it's a little bit different than what we're showing on Effects Guide. I personally think that this kind of view of things makes it quite a bit easier. Kind of simple to follow and so forth. But the problem is now, what we need to worry about is, let's say we wanted to isolate here on her tattoo. Let's go ahead and go up here to our tattoo, and scale this baby down like that, and position it up. And we want to do some kind of warp to it, right? So we subdivide our shape, and we do this to it. But the problem is, as she moves, our box doesn't move. So what we need to do is actually do some tracking on this and actually figure out how to incorporate that tracking data into what we're doing under here as well. So let's go ahead and add an axis. Position that. We'll go ahead and go into the stabilizer and just find a point here. Her eyebrow works really well. It's got a good contrast. Go ahead and analyze. Okay, return. Okay, so now we've got that set up. Now, of course, because we have an offset now, this reposition would have to be kind of down. That's really confusing to look at. So we'll go ahead and just take this transparency down to 100. Go ahead and bring this here like that. And then bring it back up. And it's broken. Why is it broken? That's because we've always been using, remember here in this axis, we use this reposition. Well, it's actually now a combination of those two things. It's a combination of this, the track that we did, and the reposition. Okay? So you got this and this put together. So what we need to do is negate both of those now. So that means our expression here becomes, I'm going to go ahead and open this baby, close that baby back up. Repo me dot position. And what we want to do is just say negative track dot position minus repo me dot position. And so now, what's happening? Well, it still doesn't appear to be working for us. And why is that? Let's go ahead and zoom back here on our source. Basically what we want to have happen, sorry, over here. We want to have this position kind of follow along with our tracker. And right now, that's not happening here. Well, that's because, again, if we go back to the center, pull down here, the center, that's just looking at repo me dot position. That's just looking at this. So what we actually need to do is also add the track back to this. Or actually, if you think about it, basically what we need to do is just negate this value. Okay, if we take a look at this, it's minus track position minus repo me. What we want is plus track position plus repo me. So what we'll do is we'll just go ahead and for this, we're just going to enter in minus position. Since we're here in the same hierarchy within this axis, it's just going to negate this value. We don't need to say axis 1. So go ahead and hit enter. And now here, if we look now, you can see that we're actually repositioning her inside our source node. It's actually stabilizing, right? Because that's what stabilize is, right? Negative position. I think I got a little bump here on my track. But you can see here now that that's working out great. And over here, you can see that works out really fantastically as well. And so all we need to do here is just, let's go ahead and take this track and we'll say copy. Oop. Go to the animation, excuse me. What I'm doing is I'm going to create a mask. So I want to get this in my buffer, so I'll copy that. Let's go ahead here in Media Layer 1 and just do a key. So go ahead and add a geometry because I just want to isolate in here on this area. It's going to be rough. Outside, offset. I know I've got that data copied, but what I'm going to do, just so I use the offset, I'll just go ahead and track this here because it tracks so quickly. Yada yada. So we got that to go. So we've got the mask tracking. So go ahead and return. And now you can see here, again, a little bit of a problem there with my track, but I've got it tracked really nicely, really simply. Perfect for fixes. Perfect for making cartoon eyes on people, what have you. Again, the key here is save this, and then you can do a load, add nodes, and all you have to do then is just apply your various layers. You don't have to redo all your various expressions and everything that you've done. You know that you do your track here, you do your repo here, and so forth. What I would suggest before saving is go ahead and take these and just reset them. So reset the track and reset the repo just to get everything back to normal. Before you save this setup. That way when you load things back, they're all centered back at 100. And it's kind of making sense for you. You know, same thing with this. Probably want this to just be set up like that. The layer mask doesn't matter because that wouldn't be loaded back in when you load things. Okay? So I hope you like that look at it. I think this version is much more flexible than our previous version that we've been showing. And also, I just wanted to show you guys how we figure some of these things out and make it easier. Again, when I wanted to make this simple, it took me a little bit just to, as you saw, you know, just try some things, see what works and doesn't work. Here are the expressions that we'll be using. I'll include these with the class files this week as well for you. But really relatively simple and, again, really easy to use. So let's move on to eval. Eval is one of my most favorite functions ever. And that really allows you to do some timing things. It also allows a lot of stuff that you see in some of the layer slip things that we'll be talking about in later courses. But what is it? Basically, it's evaluating a channel at a given frame. So you can say, okay, I'm going to eval. I'm going to take a look at axis1.positionX at frame. Now this is shorthand here for current frame. So at the current frame minus 10, so 10 frames earlier. Or you could do something like this, where you say eval axis1.position.x, comma 10. Basically, it's going to look at axis 1 position at frame 10 on everything. On every single frame, it's going to look at frame 10. So effectively, you'd get, if it was animating, it'd kind of stick in place. So let's go ahead and take a look at this really quickly and load up a setup that allows us to do that. Let's go ahead and load in this, which will look familiar. Basically, I've got a bunch of things here in 3D space. And we'll just go ahead and start taking a look at doing things with transparency. So let's go ahead here, and I'm going to set my transparency here to be 100. And let's go to frame 20. Okay, so we've got a simple fade up. And let's say that I want this to be, say, just delayed 10 frames, like what we looked at before. So we'll go animation. We'll go ahead, and I can use the entire hierarchy here because I'm going to keep these all the same. Basically, what I could say is I'm going to say eval image 1 frame minus 10. 10 frames earlier. And if you wanted to do transparency, you do image 1.transparency. Okay, but I'm just using the whole hierarchy. And so now, you can see that this is starting to fade up 10 frames after the first one. And then you could do the same thing here. We'll do this. Minus 20. This. Minus 30. And so you've got them all staggered like that. Okay, so really useful. This eval function, incredibly useful. Now, one of my problems here, though, is, you enter all these in for every single one of these, and it's pretty easy because, I've got them labeled here really nicely, image 6, 7, 8, 9, and so forth. So really easy to change if we want. And we kind of saw this last week when we took a look at that layer blur function. Once you enter it in, you're kind of stuck, right? So how do we get around that? Well, what we're going to do is use kind of dummy axes and multiplication, really, to do this. So here. But what happens if we wanted to fade these up earlier? We want to, say, fade them up, 5 frames apart, or we want to lengthen it or something like that. I mean, the great thing about this is we can take this, and if I extend this to 40, set a keyframe here, a slower fade up gets propagated amongst everything. But the distance between the fade ups remains the same. Let's say I wanted to have them go boom, 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 one right after the other. Well, we have to go back in and modify each of these. Not so cool. So what I'm going to do is I'm going to go ahead and enter in another axis. And it's just another one of those placeholder axes that allows us to do this. So what we can do is we're just going to call this AX_delay. So now if we take a look at this under animation, let's go ahead here. We say frame minus 10. Well, what we want to do, enter, is we're going to say frame minus 1 times delay. So we'll say 1 times axis_delay. And actually what we need to do is we need to do position.x. So we'll do position.x. So we'll look at the value in position x for that. So right now, there's no delay, so they come in at the same time. If we take this and set this up to, say, 30, that gets delayed 30 frames. Again, we're just looking at this flame right now because that's our one that we're modifying. Okay. If I come back here on axis delay and I say enter in 5, then it happens really quickly. So now what's cool about these is we can take this expression and we can start multiplying it. So this was the reason I said 1 times axis delay is then this will just follow axis delay.position x. But let's say we want the next one to come in at 2 times that. So what we would do is here we'd enter 2 times axis delay. Here 3 times axis delay. And here we'll just do one more for now. And we'll do 4 times axis delay. So now if we take a look at this, I've got the first 4 coming up. And what we can do is if I just change this delay value here to say 1 frame, they're all going to start coming up really quickly, one right after the other. Or I change it down here to 10. There's more of a delay. Okay, so you see what I'm doing here is using this. I don't have to go back in and modify the expression each and every single time I want to make a timing adjustment. So you kind of use those things in an intelligent way, use these kind of dummy axis and multiplication to really make things easy on you. Now there's an easy way also to actually get these entered in with all these values. What we would do, let's go ahead and go back here, and I'm going to reset. I'm going to go ahead and reset these channels for us. And actually reset all of these. I don't want to reset everything in the scene. Okay, so all these have nothing in it. What we're going to do is we're going to go ahead, we'll leave animation down here. And notice I've got these image 1, 2, 3, 4, 5, 6. What I'm going to want to do is go ahead, and the easiest way of doing this is to go ahead and take our top view up here, and we can switch it to info view. And what you do is you can switch, if you hit F5, hit F5 again, you get into info view. And now you can see a listing of these. And note this little number here. Basically what happens is you select something, it says, okay, you've selected this. If I hold down Control and select multiple things, it shows the order in which I selected them. And this is kind of used in a utility called selection order. So what I'm going to do is I'm going to go ahead, and I'm not going to use image 1. If we take a look, that's our image 1. So we'll start with image 2. So I'll select image 2, hold down Control, image 3, 4, 5, 6, 7, 8, 9. So now what I can do, as long as you have to have the animation menu up down here, I can enter an expression for each of these. And that's going to be, what we'll do is we're going to say eval image 1, okay, and we're going to say at frame minus, what was our axis called? It was called axis underscore delay dot position dot x times a special word that's called selection order. And you can see what happened is it automatically entered that expression times 1, times 2, times 3, times 4, times 5, 6, 7, 8. So basically just by multiple selecting these items, I was able to go ahead and enter that in really easily. And if we take a look now, we've got the selection order. So let's go ahead and put our delay back to 2. And we've all got them entered in really easily. So again, eval and selection order are really, honestly, your friends. Now, one thing I want to point out, it was really easy for us, since we use this hierarchy, to kind of find what we need within the channel editor here in the info view. But you can't see it because the screen's cut off the way we record. But you have columns for channel, component, and value. If you go ahead and switch to channel, you can see you get all the channels available. I just clicked on the channel header, and you can see you get everything available to you. Now this can be kind of hard to find things, but if you switch on the component, it does actually group things in a logical way, so that if we didn't need, or we weren't able to actually use the entire image hierarchy for each of these, what you could do is you could actually just go ahead and scroll down here, find the component, and if you find out image 3 or image transparency, you can actually be able to scroll down here. Should be able to find it. There's displacement. There we go. Took a little bit to find. You could actually select these here, so you could easily go, okay, 1, 2, 3, 4, 5, 6, 7, 8. So you could find things that way. If you sort by the component that's up here at the top of the screen, it becomes a little easier for you to find those things. So that's, a really good way of using the info view if you want. But in our case, we didn't have to worry about that because we were able to use the whole entire hierarchy in order to accomplish our animation here regarding eval. Well, before we go, what I want to do is just revisit some blurs last week based upon some input in the forums, which I thought was both crazy and cool. And that's the idea of, in our action setup here, using a Sapphire Z blurs, or maybe the convolve spark, to actually drive the blur. So instead of using blur, we get something that looks like a real lens defocus. So if we move our position here, let's say we move this just to 2000, you can see we start to get a lens blur look as opposed to just a rack defocus. Now it's kind of a hit in time. You can see that we get a lot of, it's a little bit hard to modify because it reacts pretty slowly. The other problem here, of course, with us is that we're using a matte and a fill, so we'd have to kind of run this separately, if you would. So anyway, it's actually fairly straightforward. What I did is actually take the Z blur spark. In the Z blur, you can use Z defocus and actually feed it a colored frame to determine whether or not that colored frame is near or far. And so what I did here is I'm going to send it, you can flip between white is near or black is near. So I'm going ahead and set it to black is near. And feeding that is actually a color correct node. And that color correct node, what I can do is actually drive the value of the gain here, and then the defocus will react. So I've got that set to context 2. So let's go ahead and select context 2. Go to my color correct node. You can see if I bring up the gain now, I'm actually increasing the blur to the maximum amount that you set your blur value here in your spark node. And then because of the universal channel editor, what we can do is we can actually drive an animation. Remember how we linked the animation before? It's effectively the same animation, same function that we used before, with just a couple slight modifications. First of all, instead of maximum blur value, I went ahead and set this to 100, which is our maximum gain. So I know when it's 100, my frame is going to be white. The other thing I did, so anywhere that there was the maximum blur value, I did that here. You can't really dynamically adjust the amount of blur on the fly like we did before. Well, I suppose you could actually by limiting this, but we'll just set our maximum blur value in the Sapphire Z blur, and then this will be 100. The other thing I did here, if you take a look at these, the setup is that instead of just focus position or axis 9 dot position, I actually had to refer to action 2 dot axis position, because within the universal hierarchy, this has an action 2 as its name. So any node that's associated with that, when you're using the universal channel editor here in batch, you need to tell it what node that's from, because it doesn't know what node focus.position would come from. So in our case, that's action 2. And then the other thing I did is just went ahead and fed this a colored frame. Now, one interesting issue when you're setting up expressions that's good to be aware of, what I'm going to do is I'm just going to go ahead and, well, let's just use her as a layer in this case. If I take this batch, and let's say instead of Houdini 101 here in my action setup that I wanted to have, let's say I wanted to have Angie. So we take this and replace this clip. And what happens automatically is our spark breaks because the front and back resolution are no longer the same. So what I do is I generally like to try and have this workaround. And that workaround is having a histogram node here. And what this histogram node is set to is just to bring it up to white. And by feeding it a source, and then here, basically it picks up the resolution automatically of this node. So I'll go ahead and double tap here. Let's replace the 101. Our spark node doesn't break. I'll take the 2K node, and that spark doesn't break as well. So automatically, it actually adjusts to our size. So that's kind of a better procedure to use than a colored frame. So I avoid using hard fixed values whenever possible in a batch schematic. Otherwise, if you want it to be flexible moving forward, if we ever did this where we wanted to have this all set up and saved, I'd want to have it easily updatable depending upon the resolution. So again, this is kind of the basic setup. I'll go ahead and include this for you guys and see how it works. Again, it's just slightly modifying the expressions that we had before, as you can see here. Again, using 100 as our value because that's my 100 gain level that I used. And then the length. And anywhere that involved something that referenced an action node, I had to put action 2 dot ahead of time to get that to work. So again, it's kind of cool. I mean, with the matte and fill in this case, the Not so sure I'd be using it too much just because I think it'd be problematic. But again, it's kind of slow in reaction and so forth. But, you know, at the same time, kind of fun to mess around with this stuff and just play. You never know what kind of experimentation you do might lead you to do something cool in the future. Well, that's it for this week. As always, appreciate you guys and gals being part of the course. I'm going to send out the setups again this week with it, as well as this Angie footage and the keynote. If you have any questions, drop by the forums. I love the contributions. Like, I love that exponential blur that made it much more like a camera defocus that was posted in the forums. That was very cool. Again, just having a blast this term. And we'll see you next week.